video showing the beginning of the cycle. This is for animal carcass processing. I'm going to show you the temperatures. Now, this particular machine I set up so that it runs off the chamber probe, and then this probe here is the one that's in the Safe-Decon unit stuck in the meat. And we had started out at 9 degrees Celsius. It was refrigerated, actually it was partially frozen, but that is the temperature on the inside the meat right there. And as you can see, we've just started to purge. We have, we're just waiting for it to come down. It's got to achieve, I forget what it's set at, I guess 60 degrees Celsius. So it's going to count down, and we're going to start our 4 pulses. The 4 pulses that I have set up for this machine, this is a Tuttenauer. This model is a 69-137 single door with load probes. But again, I'm not using the load probes as a control. But you can see here that we're on pulse 1 of 4. Normally you have 3, but for the animal carcasses, I wanted 4 pulses. Now I set this up as progressive. The first pulse here is just going to drop down to about 9 inches of pressure. It's not a big pulse. What I'm trying to do here is I'm trying to get this to blow the seals on the Safe-Decon product. This opens it up, and then the next 3 pulses will allow it to go into the meat, have direct steam and heat content inside the bag. What I found is that the heat and the temperature and the pressure between the pulses actually squeeze the meat, and when it's all done, the meat is actually very dry. It's almost as dry as jerky. And then I've figured out how to separate the meat from the liquid. Now I can actually achieve this in 30 minutes, probably even less than that. I'm quite confident that I could do a 20-minute sterilization time and still get the kill on the biological indicators. But we just ran a 40-minute cycle. Now I'm going to do a 30-minute sterilization time. And then I'm going to show you as the progress goes on. We'll start and stop. I don't want to bore you with all the other details, but I'll show you some very interesting facts as this thing progresses. Steam heat in. This is a high pulse, and I'm just going to show you as it goes through its cycle here. And then this pulse here, this low pulse, is going to be pretty deep. We should get to 26 inches. The first pull was only 9, but now we're trying to get that seal to open up on that first pulse. That requires that the seal achieve about 140 degrees Fahrenheit. I believe it's about 75, 78 Celsius around that area, just guessing. But you can see that the temperature's starting to climb. And what I have is this has 2 load probes. So we have reference 1, which is inside the Safe-Decon bucket. Reference 2 is sitting just underneath the bucket. We're operating off of the chamber temperature, so you can see these 2 are pretty close to the same. Now this is sitting literally underneath the bucket itself for the container. So these 2 should be good. This is the one that we're kind of looking at, and we'll show you the progress as these pulses continue. I just want to jump in here very quickly. Here's a trends. This is our chart, and then you're seeing the pulls here. This is where the temperature, you're starting to purge. Things go down, temperature, and now you're starting to see the correlation with temperature, and then that's the pressure. And then you can see that this pull here and this pull here, the first one was light. These are definitely deeper pulls. So I'm going to jump back and see what our temperature is going to do on the 3rd pulse and see if it starts climbing. We should start seeing more of a significant jump in temperature here shortly as we get into the 3rd pulse. You'll start seeing it jump a little bit quicker now that the pressure is getting in, and it's pushing that heat deeper into that meat. Now, the meat that I was using was a bottom round roast with all the fat, as much as I could get trimmed off. This is 2 pounds, 10 ounces of meat. And I cut the slivers, and they're in either 4, 5, or 6 ounce chunks, probably about 4 inches long and then cubed. So it really is a challenge to get the BIs done and to get this temperature in the middle. The meat was partially frozen. Couldn't really get it below 0 because the load probe, if it gets below 0, it goes into error. So I tried to get it as close as I could to 0 to test this out as much as possible. But you're starting to see the pulse low for the 4th one here. I'll get back when the pulses go in and it goes into heat up. But you can see now that most of the liquid is out and the temperature's continually to rise. So when it goes into the high pulse, I'll show you what I'm talking about. Yeah. Okay, here we go. This is where the pressure starts going into high. So now we're putting that pressure back in. And let's see what our temperature does on our probe here. We should start seeing the jump in temperature here pretty shortly as pressure gets inside. We're just now getting above atmospheric pressure, and that's going to start going. At this point, a majority of the liquid should be out of the meat. And with the liquid out and separating from the meat, we can now really get deep heat and steam into the middle, of that tissue. And of course, this is beef. It's a bottom roast. It's a dense meat, very dense, not much fat to it at all. So I tried to get as close as I could to a mouse and then some. Most mice probably don't weigh 5 or 6 ounces. This does. But you can start seeing that our pressure is going up and our temperature is going up. And then when it goes over 2, you're going to see. Now I'm running a 30-minute. The last one I ran was a 40-minute. I have a biological indicator in the middle of a 6-ounce piece of meat. Then I have a biological in the well where it collects the liquid. And then I have a biological indicator in between the bag and the container. So as you can see, we're starting to really kind of jump up there right now. So when it gets done with pulse high, we're going to go into heating here shortly, and then it'll continue on to heat up. So we're going to see, there we go, we just jumped into heating. So now everything's going to try and heat up. My chamber temperature is at 120.2, but now look at the temperature starting to jump. Now instead of by 0.1 or 2, our temperature now is starting to really jump by 5, 6 degrees at a time. This is what I wanted you to see. This is why the 4 pulses are important. They have to be 4 deep, or 1 shallow, 3 deep ones. And as you can see, our temperature is really starting to climb up there fast. Once that liquid gets out of there, this is what happens. You won't see it go down either. And by the time this goes into sterilization, our temperature inside the middle of that bag should be at sterilization temperature or pretty close to it. So I'm going to hang in there for a little bit and wait for it to kick over into sterilization, and let's see what the difference is in between. Okay, our chamber is now at 122, and let's see how long it takes before our meat achieves the 121 that we need. So with 30-minute sterilization, we're still climbing pretty quickly. You can see it's really, really jumping up. Yeah, keep going. We're almost there. Sorry for the shaky hands. I'm using my iPhone to do this with. So we're a minute in sterilization and the chamber temperature is there. Now I'm just waiting on the probe that's in the middle of the meat. And again, this probe is sitting in the middle of about a 5 or 6 ounce piece of meat in the middle that was partially frozen. Not 100%, but just partially. So we are at about 1 minute and 30 seconds almost, and past the sterilization of the chamber. If you have a load probe that controls it, then you really have more control. But I really wanted to kind of challenge this as much as possible. Let's see how long it takes before the center of that meat gets to 121. There. We're just a little over 2 minutes in. The last run, it actually achieved sterilization for the middle of the load when it kicked over. This was the biggest piece of meat I could find, and there you have it. So 2.5 minutes later, we have 27:30, we'll call it 27:30 left on the sterilization cycle, which is more than adequate to give us a good BI and a good kill on anything that's in there.